evaluated in the different feeds are concerned. So we need to consider the protein as one of the important source of the animals for feeding. Then the common methods is to measure the crude protein. So then crude protein is estimated by the method of, as you know very well, that the Johann Zeldal or Denmark method in 1883. So the nitrogen estimation was done. All food contain about the 16% of nitrogen as an average. Whereas the crude protein or non-proteinous nitrogens, they make the major part of the protein source. Whereas the true proteins are to the extent of 95%, then especially from the mature seeds of certain crops. Whereas the leaves, they also do contain 80 to 90%, stem 8 60%. So the remaining occur as the amides, amino acids, glycosides, alkaloids, ammonium salts, then the compound lipids. So we need to get the estimation of the factors which converts nitrogen to crude protein. Actually, the nitrogen is the main source of the protein, so it is measured instead of available nitrogen per kg per gram per kg of the feed. So the require the especially the nitrogen which is present in cotton seed is highest, especially it is 189 gram, and if you convert that factor, it comes to the extent of 5.3. Then soya meal is 175, then 5.71. This is a conversion factor. This has been made based on certain observations. Then barley is another protein source which is containing about 172 grams of the nitrogen out of 1 kg of the barley. Then oats 172, wheat 172, maize also is also source of the energy. At the same time, it's also sources of the crude protein about 160 grams per kg, whereas the egg, if you consume the poultry egg to the human beings, then it contains the nitrogenous substance to the extent of 160 grams per kg. Then milk is also another source of the protein in the human feed is concerned. Just for reference, then these are all the conversion factors, especially the different conversion factors are added. So what are all true proteins? It's so called as the Sturger reagent, means the alkaline copper sulfate is used to precipitate the two proteins, and the nitrogen is estimated by the Zeldal method. So one need to remember that this method is also another important method to estimate the crude proteins, true proteins. Whereas the DCP is only for ruminants because the protein can have same digestibility and yet differ in their value, especially in case of the animals. DCP is crude percent into digestibility. Digestible crude protein is crude protein percent in a feed and the percent digestion especially. For example, the CSM, the protein is equal to 35%, then digestibility of this one is about 65%. Hence, the DCP can be calculated into the 35 into 65 divided by 100. So it is the factor 22.75. So because of its easy calculation, DCP is widely used in the calculation of the protein value of a substance. So this is very widely used. Then the OSCO reported that the nutrition relevance of the DCP for ruminant is rejected nowadays because the dietary protein is largely degraded in the rumen most of the time, and extent to which nitrogen is degraded in rumen, utilized by the rumen, related to the availability of the energy. Hence, the several new systems were proposed, like how to calculate the rumen degradable protein. Number one, we have already known that some proteins are digested in the rumen and they are called as the rumen degradable protein, whereas some of these bypass the rumen and go to the abomasum, and these are called as the bypass or rumen undegradable protein. And the metabolizable proteins are also there. And the fundamental concept is the nitrogen requirement of rumen animal is the nitrogen requirement of the rumen microflora, because totally the ruminal digestion is depending upon the type and quantity of the ruminal microflora, and nitrogen required for the host animal is equal to the microbial digesting protein. RDP is the portion. Ruminal digestible protein is dietary protein, degraded in the rumen. How to calculate this thing? So the different methods of estimation are there. The in situ or in sacco or nylon bag method is one of the method. Whereas another method is enzymatic method. Then the third method is in vitro method. In vitro rumen fermentation methods, and already the artificial rumen etc. are created by using the optimum environment, the pH and the food ingredients. So the NIRS is one of the method where in which the near infrared spectroscopy is also used to calculate the RDP. Whereas the buffer soluble nitrogen, then ADIN or acid detergent insoluble nitrogen. These are need to be estimated for the RDP calculation or rumen degradable protein calculation. So the metabolizable protein system includes the rumen degradable protein and also the UDP. So this RDP requires the ruminant fermentation, especially the microflora are the one which are going to utilize the protein to form their own nitrogenous substances, and ultimately the nitrogen is utilized by the microbial flora to get their own protein or to synthesize their own protein. And there is the mixture of peptides or free amino acids and ammonia required for the microbial growth and activity of the system. So ultimately, whatever may be the protein which is converted by the microflora are once again utilized by the host ruminant. Then the UDP is direct source of digestible amino acids to the animal available for the utilization at tissue level. So this system is available in a lot of varieties. You might have heard yesterday we have seen what are all the types of the systems: ARC, NRC, of course it is from US, and ICR system, especially the 2000 system. The ICR itself tried to evolve their own type of the feed metabolism systems, whereas the NRC is universally accepted and it's from US. And every 1 kg of OM degraded in the rumen, then 30 gram of microbial protein is synthesized. So that's the calculation how one are going to calculate it. Whereas the protein requirement is an attempt to have the non-proteinous fraction of the half of initiative value of the protein, and the PE or protein equivalent is introduced. So what's a protein equivalent? It is percent DCP plus percent DTP divided by 2. Whereas The PE means protein equivalent, then digestible crude protein DCP, DTP means the digestible true protein. So this is the formula how the protein equivalent is calculated. So the protein evaluation for non-ruminants means the monogastric animals like pig, then also the horses. So they are all non-ruminants. Then estimation of the quality of from amino acid composition is, of course, it's limited. It's tough process also. Then another method is the chemical method. Does not give the value of availability of animal for utilization. So this is one type of in vitro estimation. Whereas the biological experiments are always used where weight gain is due to the protein or other nutrients is not now need large number of the animals and time and labor and also the animal ethics permission. All these things are there to calculate the rumen evaluation for non-ruminants. Then there is another method called as the biological assay of the available amino acids. So coming to the one by one, the chemical method of estimation of the amino acids is especially it is calculated by Black and Mitchell in the year 1946. The concept of this is quality of the protein is decided by that constant indispensable amino acids to the extent of 10, which is in greatest deficit when compared with a standard. Hence, the example percent egg protein standard and percent wheat protein standard are known as the test protein standards for the animal feed origin and also the vegetable feed origin. So the chemical scores of the maize is 28. It's a number, and most deficit amino acid is the lysine, especially in case of the maize powder. And lysine content in the maize is 2%, especially of the test protein. Egg it is 7.2%. So the chemical scoring is called as 2 into 7.4, 2 divided by 7.2 into 100 is equal to 28. So 100 minus 72 is also equivalent to 28. Oh, that's how it is derived by this particular formula. Then drawback of this chemical method is only one amino acid and not other about the A. So the amino acid present in the greatest deficit is considered as the limiting factor, and also it is chemical score than that of the protein. So this is also not a completely perfect method that can calculate the quantity of the amino acids or the proteins. So calculation revealed that by a system that is lysine is most limiting amino acids, especially in most of the feed ingredient, the lysine deficiency is there, and hence about the huge deficit of the 72% is there. Hence, the chemical score of the maize is equal to 100 minus 72. It is just 28% from this particular formula. Then essential amino acid index is also noted by EAAI. This is found by B.L. Osler in 1951. So include all the 10 amino acids, essential amino acids. It is geometric mean of all the 10 essential amino acids. Then this contains in a test feed with reference to the egg as standard for considering egg protein as 100% or it is a standard protein. So this can be calculated by square root of the 10 into 100 A into divided by AE, then 100 B divided by BE, 100 C CE, then the net answer is 100 J divided by J or into J. So this is the first essential amino acid index test for the field, whereas all these AC, ABE, or EE can noted to the different types of the feed also. Then the advantages of this method is this can be easily estimated without any animal. It's a in vitro technique. Whereas the disadvantage of this method is protein of different amino acids is not known, and also the amino acid which is essential to the animal's life is not known properly, and both chemical score and EAA. Why? Based on the gross amino acid composition, but not on amino acid availability. And hence, the total AA cannot be combined with that of the other compound. So, this is based on both chemical and all these things are used for the pure chemical method. Then another thing is the Maillard reaction, or this is one of the important reaction throughout the world, and it takes one of the most famous sentence, and one need to understand what is this Maillard testing reaction. So this is a reaction between sugar and amine formation, sugar and amine formation of the melanoids, melanoidins, non-enzymatic browning reaction. Then epsilon amino acid group lysine react with the aldehyde group for of the reducing sugar. This happens in the uh, rumen of the animal. So ultimately, the produced products are the glucose or lactose to yield the final amino acids. So the exogenous type of the protein cannot be directly considered as the feed source of the animal. So glucose, lactose, these yield amino sugar complex that is no longer available to an animal as a result of compounding. So, trypsin can no longer cleave the peptide bond, the trypsin, and also lysine is not available. Then biological experiment methods is the different digestibility tests are there, and it requires the animals, especially pig, poultry, and also the laboratory animals, and also the cattle. Then conduct digestibility trials. Most of the research works are depending upon the digestion trials and feeding trials, but this is too much time consuming, long standing, then also the equipments required and continuous monitoring of the particular test need to be conducted always, because the animals do have the life. Digestibility coefficient of the protein is protein intake in the grams per day. Then protein outgo in dung, that's also calculated as grams per day. Whereas the protein intake, how much quantity of the protein is being intaken by the animal, is also measured in case of the grams per day. Later, what it's happened? So, digestible crude fiber is calculated by this particular formula. For example, the protein intake, then protein outgrow and protein intake divided by. So, this gives the digestibility of the crude protein. So, another method, weight gain method, is also there to calculate the protein efficiency ratio. It's also known as the PER. So this is the weight gain per unit weight of the protein consumed. So that simply it is the weight gain of the animal per unit weight of protein consumed by that particular animal. So it's also known as PER. And everybody who is having the knowledge of protein, or they know the PER, or protein efficiency ratio. So it is the weight gain by the animals in gram, then gram of the proteins is which is consumed by the animal. So continuation in nitrogenous free diet, to which protein sources to be compared are included for different group of the animals and record per consumption of the feed and growth. So the protein efficiency ratio, or PER, is calculated of the meat, milk, egg, and egg to the extent of 2.6 to 2.8. But the protein efficiency ratio calculation is one of the most tedious method. Cannot access digestibility of the protein. Just it cannot measure how much of the protein fed is used for the different purposes of the animals, like the maintenance of the body functions, then the tissue formation or the growth, then weight gain may be due to bone or fat formation and also the muscles. Then net protein retention, or NPR, is modified form of the PER. This makes allowances for the maintenance. So here is the formula: weight gain in test protein, or the known protein is taken, then weight loss in protein free diet. So the formula has to be remembered, then the gram of protein consumed, then more accurate than PER, what we have discussed earlier. So another value is the GPV, gross protein value, is equal to gain in body weight in test protein feed. The gain in the body weight. Simply, we are not going to calculate the percent gain here. So varieties of the formulas can also be given, and we should be able to get it done. So if you go on extra live weight gain per unit of the supplementary of the a test protein, stated as the proportion of extra live weight gain. Weight gain means, live weight gain means, it is not the total weight gain, but it is the one in which the actual performance will be is deducted in the body weight, regular body weight. Then nitrogen balance experiment will be conducted in a nutrition laboratory. This is more advantage, like the accuracy, then total nitrogen content, then nitrogen excretion proportion, like the dung, urine, milk, egg, hair, skin. So all these are the components of the protein source. Whereas the total nitrogen intake may be calculated as the total nitrogen outgoing. It is also defined as the positive for growing and the other animals, like the producing animals. So it has got its own limitations, like it is more expensive, and certain feeding only, regular feeding only, this can be applied. Whereas the third part of this is need technical expertise. One need to be very much expertise by having the hands-on training program, and many times the doctors or the scientists are put the restriction on use of such type of the things. Then the biological value is another value need to be remembered by the applicants. So this biological value, or in the bracket BV, divided by the not applicable to the ruminants, because the microbes are always there for a very short span of the time. Later they are going to be get dead, then either digested by the ruminant or excreted through the urine. So the nitrogen intake, or NT, is equal to Ni minus fecal nitrogen plus urinary nitrogen into 100. So this formula is based on the energy and protein requirement of the cattle by balancing the diet. So there are varieties of this BV is being affected by so many factors, or the biological value of a animal is bigger than that of the appearance of the BV. So the factors affecting BV: age, then species of the animal, amino acid composition, then source of that particular protein, or origin. Is it a non-proteinous nitrogen, or directly it is converted from the actual source of the protein? So the biological value of a protein is equal to the low, because BV, because imbalanced feed, if it is not properly done, then the deficiency of lysine is always one of the criteria, and sometimes the methionine can also be the deficient. So the suppose there are different diets like the B and C diet, then we need to properly balance it. Then net protein utilization, or NPU, is defined as the biological value into digestibility in the percent proportion of nitrogen intake which is retained. Has This has got low significance, whereas the protein replacement value, or the PRV, is equal to A minus B into 100 divided by nitrogen intake. So here the Merlin devised this method where A is equal to nitrogen balance in a group of animal which is fed with standard protein source, means already it is a calibrized thing. Whereas the B is the nitrogen balance in the test protein source. So weight gain methods are less accurate than that of the nitrogen balance method. So please remember this thing: weight gain methods which are followed, but they are less accurate than that of the nitrogen balance method. So nitrogen retention method in the body is the composition of the nitrogen content which results from test protein that resulting over the same period of the nitrogen free diet. Hence, nitrogen retention in the body is equal to body nitrogen retention minus body nitrogen content with nitrogen free diet divided by the total nitrogen intake by the animal. So the as we have dealt yesterday's class, the measurement of the energy requirement for the growth, the maintenance, and also the animal killed after experimental body water determined and nitrogen calculated from body water. So this is the actual analysis of the nitrogen after the animal is died. Estimation of the available of amino acids is biological uh, assay. Then it has got its own advantages. Then the weight gain, feed conversion, feed efficiency, or the retention of the animal given intact protein is a supplement to diet, and the deficit only in the amino acid under investigation. So the poultry, it is very high successful for lysine, which is deficient in different feed components like the maize, etc. Then the very essential amino acids like the lysine, methionine, and cysteine. These are essential amino acids. Later, they become the substrate of the bacteria, and of course, we can calculate it more efficiently. Then varieties of the other methods like the microbial method is one of the method. Microbial method is one of the method that is estimated by the microbial uh, microbes like the Streptococcus zymozynes, a bacterium for the methionine estimation. So we are utilizing some of the bacteria like the Tetrahymena pyriforms. It's a protozoa for lysine estimation. Then we have the amino group requirement of the higher biological of the animals, especially measure the growth of microorganisms in a culture media for test protein. So this is of course more near to the accuracy. Then chemical method is also known as the KJ Carpenter method. Then the here FDNB is calculated by the reactive lysine method, and most promising method to test availability of the lysine. That's the FDNB method, as we have already known. Whereas the free epsilon or different amino acids group of lysine in protein will react with chemical or also called as fluoro 2,4-dinitrobenzene. Then the depth of the color indicates the availability of the lysine. So dye binding test is another method where in which the cereal, milk, etc. are used for measuring the total basic quantity of the building blocks. Then reactive lysine, the latter means it's also the lysine content. Require blocking the epsilon amino group to prevent its reaction with the a dye which is used for the estimation of all these things. So orange G means along with 2,4,6 trinitrobenzene, sulfonic acid, and propionic anhydrous. It is known as the orange G. Here what we can say, the orange G, then effective in estimation of lysine content. one of the most essential amino acids. But it has got its own limitation always, as usual, with many of the people. Then the limitation here is preparation of dye is difficult and need technical expertise always. So it is difficult and time consuming. Then money is also required. Hence, the ileal digestibility of the protein is T cannula is fixed. Then digestibility coefficient is uh, on collection and analysis of the digesta from the terminal ileum, especially the latter animal, and most accurate methods, especially. In case of ruminants, the large intestine do not have any of the protein status of the animal because the large intestine, bacteria of this large intestine, whenever there is a change of a consumption of undigested uh, food residues, these bacteria add as their will change the valley. So apart from this one, many more methods are there, and we need to have such things, especially while we are preparing the common food to the people. So the AA or EAA are important, especially in case of the ideal protein concept or earlier reference protein concept for the pig and poultry, which are monogastric in nature. In poultry, evaluation of the protein is based upon the content of three major limiting amino acids. Number one, lysine, methionine, and another one is the tryptophan. So, in it is generally assumed that the diet adequate in these amino acids will automatically provide sufficient amount of the other amino acids, which are almost different. Not only the lysine and methionine, many other amino acids are also required. So there is a recommended balance of amino acid in ideal protein. So it can be obtained by EAA minus 404, then NEAA by minus 596 is there. So ideal protein is the one which contains the adequate quantity of the formed protein already. So the requirement of the cattle is like that: lysine 70, methionine, and the cysteine, isoleucine, then threonine, then the valine and phenylalanine. So this is the method how we can estimate the quantity of actual protein which is present in a source of the true proteins. So example 2, if main limiting amino acid was lysine at 50 grams per kg, then of crude protein, then the score would be 50 out of 70 or zero point 0.7, and the ideal protein content will be 700 grams per kg per day, or a ideal diet with 170 grams per kg of this protein would be then supplied. Then kernel net carbohydrate and protein system, or it's also known as CNCPC. So, most widely used and sophisticated multi-chemical approach of the uh, feed stuff. So this can be routinely performed in a field suitable model and product this precluded as the accurate microbial growth and also rumen fermentation is there. Whereas CNCPS or kernel net carbohydrate and protein system is uh, partitions of the CP crude protein into five fractions using three solvents and protein precipitating agents. So the beta 1 no, B1 rapidly degraded to protein soluble in borate phosphorus phosphate buffer. Then this precipitates with the tungstic acid. So there is a specific reactions are there, and these chemicals need to be observed by the persons. Then beta 2 or B2 moderately degraded to protein and the large peptides. So this is calculated as difference between the crude protein and some of the above said the 4 CP fractions. So another newly derived system is the B3 slowly degraded true protein and large proteins and calculated as difference between the neutral detergent fiber or the undergraded crude protein or true protein. Ultimately we need to convey this as measured ADICP. So that's the end of this particular topic is concerned. Hence, focus very well on each and every topic. Study very well, especially for the different question paper. And I have seen that many of the participants has not